see you again. This session, why AI needs better questions for science and better bodies for robots. So we're going to deal with everything in about 20 minutes. Look, you posted on X recently, and you said that you're afraid that AI won't give us what you said, compressed 21st century, this idea that the 21st century scientific discoveries will happen within a 5 to 10 year mind frame. And you said what we'll actually get, in your opinion, is a country of yes men on service if we just continue on these current trends. Could you just lay out kind of your thinking here and what you were alluding to?
Yeah, of course, with pleasure. So, I mean, I think this is something we've all experienced. I mean, I assume everyone here has played with ChatGPT and know that. ChatGPT always thinks you're absolutely right, even when you're very wrong. So I think this is really what AI models and LLM are nowadays, which is you can tell them, the most wrong thing, and they will always be aligned with you. And that's generally, that's a much wider problem. So when I say, maybe just going back to the beginning, what is this compressed century you were meaning? So this is an essay from Dario Amodei, who is the founder CEO of Anthropic, where the essay is called Machine of Loving Grace, and he kind of laid out, the very optimistic, positive view of the coming 5 to 10 years, and even actually the full coming century with AI. I think it's a great essay. Everyone should read it. And I want also to prefix what I'm going to say by saying definitely in the side of very optimistic people about AI and the potential of AI. So in this, he laid out how AI can bring us to invent new proteins, to solve some of the most difficult biological challenges, and then go to neuroscience, solve mental health issue, and then even go to solve world peace. That's the end of the thing. So you may or may not agree with that, depending how politically you think the world is going and how deeply worried or not you are by the current tension. And so all this is is based on the fact that we think AI is going to be able to invent new things. And when I say to invent new things, I don't mean just small things, but reinvent things of the order of general relativity or maybe quantum mechanics. So these things are typically what gives someone a Nobel Prize. So this type of scientific breakthrough, we have maybe one per year, and typically that's a Nobel Prize, but maybe not even. Some Nobel Prizes are actually quickly forgotten, and some of them are very, very important. So maybe we have one of them per decade. And if you take the pace of science, actually, these huge breakthroughs are the ones that really set the pace of science. And everything in between is kind of incremental progress, in particular in physics. And so I think AI is very good at helping for this incremental progress. So when we have an idea of a protein, exploring the variation of these proteins, when we have an idea of a new drug, or when maybe we have an idea we have a scientific theory for something and we want to test some edge case or extend. It's very good at that. It's very bad at the very fundamental breakthrough. And the deep reason about that is, if some of you are scientists, or if some of you have been around very good researchers, what you will see is that they are very nuts. They will never say something like, you're absolutely true. They have a very contrarian view of the world. Mm-hmm. And so that's why they can say, like Einstein, they can say, everyone thinks, the speed of light depends how fast you go, but maybe the speed of light is the constant. Or maybe like Galileo, let's say, okay, everyone has been talking about how the sun is revolving around the earth. I think everyone is wrong. I think it's the sun who is at the center. So you need, when you want to do like a huge scientific breakthrough, you need this thing where you say, everything that everyone's believing is wrong, and I think I'm the right person, the person knows the right. LLM are very bad at that right now, because they agree a lot with us. And that's something I found extremely frustrating.
And that's a really important point. When we think of genius in the past, sometimes it is contrarian thinking. It's people who think outside the box. Sometimes it's accidental as well. I mean, how do you introduce that kind of thought into a model?
So I don't think we should, by the way, I don't think we should whip out all deep learning and everything. I think it's definitely part of the solution. But the way models are trained right now is really to predict the most likely next token. So they really try to predict the most likely next word. But the scientist is not trying to predict the most likely next word. He's trying to predict this very, novel thing that's actually surprisingly unlikely, but actually is true. So I think it's mostly in how we train this model, in a way, giving them the right incentives, And so we see there is a couple of new companies, mostly this year, who try to tackle this, which is really creativity, but creativity of the, really the next level order. I don't pretend LLM can't do some creativity, but I don't think it's high enough to what I would like to see, which is, let's say, in 20 years, we want to travel faster than light. How do we invent this new theory?
Yeah. You talked in that post as well a bit about the way we benchmark some of these models at the moment, and there's these set kind of tests, and we compare them with each other. And you said perhaps one of the things that needs to change also is the way we sort of benchmark these models. So what to you seems perhaps a good way forward to benchmark models to the standard way they would be needed to create real breakthrough?
So I think the way we benchmark these models nowadays is we ask them a set of questions of which we know the answer. And even the most modern, right? So we've seen a lot of really good development over the summer for AI for math. But it's always the same. We have a theorem, or we have a conjecture that we know is quite true. Some mathematicians have invented this conjecture. And then we ask it to prove. We ask it to not ask the question, but we ask it to basically give the answer to a question that we know there is an answer. So as a student, I was very good at this type of things. I was also very good at giving answers to problems that I know there would be an answer. And when I did my PhD in quantum physics, and someone told me, now you're not here to write answer, you're here to write question, I was totally lost. I was like, I don't know how to write a question. So we should find a way to benchmark this model so that we don't ask them to give us answer to things we know there's an answer, but to ask us questions that we think are interesting enough to foster like a whole research field on top of them.
As these current models get more advanced, is there a chance that these ones being made by some of the leading AI labs currently would be able to do the kind of things that you're suggesting as well? A lot of these big players are talking about AGI. I brought it up in my last discussion here a little while back. Again, varying definitions of what exactly that is, but if we just take it to mean a lot more advanced AI, do they have a chance to achieve what you are thinking, or does it need to kind of be completely recomposed?
Not yet. The most likely thing I see right now is having them being better and better co-pilot for scientists, which, I mean, don't get me wrong, I think it's something very useful to be a good co-pilot for a scientist. So someone has an idea, and you can quickly help this person test its idea and explore in the literature. So I think right now a lot of scientists use them as kind of a very fast, super smart search in the literature for their new ideas. I think that's what we will see. And then the level of like new creativity or way to like, for instance, let's train a model only on, this body of knowledge until 1990, for instance, and then ask it, ask it if it can discover one of the theory that became a Nobel Prize in the time after. This type of thing could be something that could lead to maybe a, new type of benchmark, a new type of evaluation that would drag the model research in the right direction or nudge it in the right direction.
Yeah. In terms of the actual data required to train the kind of models you're thinking about here, currently, of course, the models are trained on huge amounts of public data, scraping the entire web, stuff that's out there. And you suggest that that's partly the problem, because it's just being able to regurgitate what's already out there. So then in order to create a model that is able to think deeper and create these new solutions, does it require synthetic data? Does it require a rewiring of the model? What exactly is it in your view?
Yeah, I don't pretend to have the exact answer, but I think synthetic data is probably one of the... I mean, in any case, for these models, you just have two things. I mean, the architecture itself has been now pretty stable. You just have the data you put in, and then what we call the incentive, or which is the loss function or the evaluation. And these two are the part we should tweak. We're kind of running out of data, like you're saying, basically. So all of a lot of the recent developments in the model have been around synthetic data. So I think that's probably the area people will try to explore.
Yeah.
And gathering maybe more real-world data. So there is this shift now to what some people call physical AI, which is let's get AI maybe in the real world with maybe robots, but also maybe more like, we generate, for instance, in science, like synthetic data using, for instance, in quantum we use DFT, density functional theory, so we can model how actually, the atom interacts, and we can use that to generate a lot of data that are kind of synthetic but generated with old method, and then we can train AI model on top of that. So this is the type of data I think that will be interesting.
And what's the role of open source in all this, Tom? Because you have been a big proponent, of course, in open source, but at this same time, some of these closed labs are just practically raising bottomless funding to pursue,
It is, yeah.
these kind of endeavors. So where do you think open source has a role to play in this future?
I think it's the never-ending, battle between the rebels and the Dark Vader Empire. I don't know if it's exactly to this point, but I think open source has a lot of great things to build, and you see that actually in this, which is all of this collaboration. The open source, by nature of its philosophy, is a great platform to collaborate and foster novel ideas. And if you take actually even the current AI models, a lot of the architectural discovery that are in these models have been done in open source settings. So I think for this also, the way we try to do it at Hugging Face is to do a lot of collaboration, to try to bring people around the table, for instance, to build one data set from a lot of disparate data sets, to try to convince some companies to open source their data sets so that academia researcher can take a look and maybe have ideas. Everyone in these labs, or like a lot of people in these labs, do have this tendency to think that they can have the answer to everything. My deep belief is the more people you bring around the table, the more you open it for academia, for university, for nonprofits, the more ideas you actually will be able to generate, like catalyzing, basically, invention.
If the current trajectory of these AI labs is very much focused on these kind of co-pilot style of AI as it stands, is there a bunch of money being misspent right now, given the billions we're seeing going into infrastructure, the valuations that we're seeing in the space?
It's hard to say because on the one hand, it was definitely a good idea to put some money in AI. I don't think anyone will deny that, even though it looked crazy, right? I remember when Sam Altman was saying for the first time we're going to put 1 billion and then 10 billion. Everyone thought this order of magnitude was way too much. It does create kind of a self-reinforcing, like a loop of excitement and then interest. And also, what I think is very good in a way is bringing back students, like the novel generation to this field. A lot of them, when I was studying, for instance, the main thing when you were good in math would be to go do finance, which is great, but now a lot of them go do AI. And maybe if they go to do AI and science, maybe they'll actually be the one inventing this new breakthrough. And they go to do that because it looks exciting, because there's all this big company being built. So I think it's a good thing. Yeah.
You mentioned earlier about physical AI, robotics. Where does that fit in then into kind of the vision you have of an AI that is able to create breakthrough?
I think it's two-way, but the very long term is I would love AI to be more than just a chatbot. I think to have like much more impact in our life, and not only by like gluing us on our screens, but actually by building things in the real world. So robots are one part of it. I think robots are very interesting because if you picture a future where AI is extremely intelligent and the only remaining task for human is just to carry this paper from here to here because AI cannot carry paper, that's a very sad future, I think. So we have to be robots, I think. We have to see how we can integrate them in society. And here again, I'm starting from the point that I think open source is great because everyone can be involved. You can have the model running locally on the robots. You not have the robots controlled by a data center somewhere else. So I think robots are very interesting for that, but also for science, because science, you can invent new theory, but then at some point you have to test them. Science is the ultimate thing where actually if your theory is wrong, and if you cannot test your theory, it's not even a theory, right? If you cannot test your hypothesis, if you have a new idea on how to combine quantum mechanics with general relativity, you have one of these new string theory, the first thing people ask is, what will be the experiments we can do to tell if this theory is right or wrong? And then you have to build it and do it. And that's where actually you want AI to jump in the physical world and actually help you close this loop of experiments.
Yeah, interesting. What is the market for you for robotics? Because at Hugging Face, you've recently kind of launched into robotics in various ways. And I know you've got the very small, very cute robot, but also humanoids as well as another part. Whereas you've got many who are looking at humanoids as the ultimate end goal. This is where we're going to get to, and they're going to do everything: wash the dishes, cook the food, and work in factories. But what is the market for you really for robotics?
I think for us it was a big bet when we started to go in robotics. We were like, is there yet a market? Is there a community to address? what we were very surprised, and we started now almost close to 2 years ago with on software and then going to hardware. We were really impressed by the enthusiasm, like by the size of the community and how it was quickly growing. And maybe even more significant was the fact that a lot of this new community around robots that is actually using Hugging Face tools is people who are not traditionally roboticists. They're like investors, they're like new entrepreneurs, they're like students. Maybe I even have some friends, they were studying economics, and they're like, I want to know what's this robotic stuff. And so to bring these people in robots, what we discovered is you cannot tell them, if you want to join the robotics field, you have to buy a $30,000 humanoid, because nobody's going to do that just today. So what we decided is to lower the entry barrier as much as we could. So first releasing a $100 arm, and then we were like, we saw actually really thousands of people using it. I think we have more than 4,000 to 5,000 of this robotics arm in nature. And then we thought, now we want also something that actually you can, this robotics arm was a little bit with wires everywhere, but if we wanted something cute, so you can actually do robotics with your family, and you can maybe involve your friends, involve your kids, and kind of join this field without feeling like you're like a weird person, like soldering stuff. And so we released this summer these very cute desktop robots, also $300, with this idea that it should be something that's very accessible to bring you in the field. And we were really amazed by the reception of that. Like we sold like $1 million of these robots in 5 days. That was crazy. And so then I had to find a way to actually manufacture these thousands of robots, which we're still doing.
But then in terms of what the use cases are immediately, it sounds like for you it's about growing a developer base, growing a field.
Yeah.
But in terms of the use cases for these robots in the future, what do you see as some of the key ones?
I think there are many, yeah. So obviously some of them are really already starting to be explored. I think all the use cases around like retail, factory, I think a lot of interesting companies are starting to explore that. Some of them are actually using our $100 arm. What I was very interested with these new robots called Richie Mini was to explore also the field of more entertainment, fun. Because I think these robots have also a lot of potential to be actually just interesting, you know, new interaction. It's nice to interact on your screen with ChatGPT, but if you could physically embody the AI, it would be also very interesting as a way to interact. So, for instance, just taking example of my kids, I like to vibe code and show them AI. If we could just code on a cute robot, like have him interact with us, they would love that actually even more. So that's one of the ideas. And the way we see these robots actually is a little bit like an iPhone. So we release it, there will be like a couple of apps, maybe 10, 15 behaviors, but then it's an open ecosystem, just like the App Store, where new developers will be able to bring new apps and new open source or closed source, whatever they want, new behaviors to the robot and share it with the whole pool of thousands of robots. So this is kind of a growing ecosystem, growing community.
Do some of the, just tying the first part of our conversation together with what we're talking about robotics, do some of the current limitations with AI models right now also present limitations when it comes to physical AI?
Ooh, that's a very good question. I've not prepared this one. But yeah, I think there is some common points. Yeah. I think one issue there is probably that what people would discover with robots is we're really in this data challenge field. So we don't have a lot of data about the real world. We have a lot of text data on the internet. We have petabytes of text data. But like real data on, you know, how do you load a dishwasher? How do you fold clothes? Very few people, you know, are just filming themselves folding clothes and uploading it on YouTube. They should do that more. And so there is the data crunch. And that's also why we think it's quite powerful to have these robots on Hugging Face, because we have this open platform where people can share their data. And for instance, with the ARM, we see already, like, I think we have between 6,000 and 10,000 data sets already uploaded. We have, I think, more than 1 year of video that people uploaded on them using the ARM. So hopefully this can actually also solve a part of this data challenge in robotics.
Great, Tom, we've got about a minute yet. I'm going to ask you the same thing I asked Kevin Scott when we ended our session. If we're sat here in a year's time, what do you think we're going to be talking about?
I think probably we'll have 2 robots on both sides participating in the discussion, and that would be also very fun.
That would be very, very cool. Well, Tom, thank you very much. Thomas Wolf from Hugging Face, everybody. Round of applause.
Thanks, Adil. Great job.